Hello and welcome back. We're going to look at solve and write subtraction equations on pages 533 through 534. So you should have these two pages in front of you so that you can take notes as we go through them. Okay? Alright, the first part, it says, how do you solve subtraction equations using models? And the story they give us is Zach gave 5 trading cards to his sister. Now he has 41 cards. How many cards did he have originally? So what do you know and what do you need to find? Pause and fill those in. Alright, for the what you need to know, or what do you know, Zach gave 5 trading cards to his sister and now he has 41 cards. For what do you need to find? How many cards did he have originally? So where did he start is what we're looking at. So down below it shows hands-on activity and it gives us our step-by-step directions. Step 1 says define the variable. It says to use variable C to represent the number of cards that Zach had originally. So when we use our bar diagram in example 2, we're setting it up as the whole bar represents C, which is the number of cards that he had originally, and then for the sections of this, we know that 41 cards he has now, and 5 cards he gave to his sister. So it tells us the total length of the diagram shows, and you should fill this in. And then the number 41 represents, the number 5 represents, and then set up the equation. So please go ahead and fill in step 2 now and pause. So the total length of the bar diagram shows the original number of cards. The total number, the 41 represents the cards he has left, and number 5 represents the cards that he gave to his sister. So the equation you should have written down will be C minus 5 equals 41. So we're going to work backwards in step 3 and we're going to rewrite the equation as it was an addition sentence. So remember that when you're going backwards, when you're working backwards, that we would take the 41 plus the 5 and that would be equal to C. And so if you do 41 plus 5, you find that he originally had 46 trading cards, which if you look at this, it's pretty obvious that if the original number was 41 and 5 cards, he had 46 cards to begin with. Alright, so the next thing is we're going to write and solve a subtraction equation using a bar diagram. The first one says Mariska gave her friend Elise 8 beads and was left with 37 beads. How many did she have originally? And we want to fill in what the entire thing represents and what our 2 parts are that we have here. So go ahead and pause for a moment, see if you can fill that in, and we'll go over that one together. Okay, to do this, I'd like you to go back and glance back at our step-by-step process that it showed us in the last example. So it said that step 1, we needed to define the variable. Step 2, we need to use a bar diagram to help write the equation. And then this is going to be our equation. And then step 3 was work backwards and rewrite the equation as an addition problem and solve that. So the first thing that I did was define the variable. I've just determined that I'm going to make my variable x, which represents the number of beads originally. And the second part, I'm going to set up my bar diagram to help write the equation. So I've set up my bar diagram that this represents, the entire thing represents my beads originally, which is my x. And then for this section, I wrote how many beads that she's left with. And for this section, I've written how many she gave to Elise. So if I'm setting up my equation, because it does say to write and solve the equation, I'm going to set up originally my first equation, which is x minus 8 is going to equal the 37 beads. So that's the first part. Now that's the writing. Now I need to solve it as well. So there's 2 parts of this. Now going back, it says to work backwards to rewrite the equation as an addition sentence and solve. And so to work backwards, I could say 37 plus 8 equals x. And if you do 37 plus 8, you'll find that x equals 45. And that's how we work it out. So using those step-by-step, define the variable, use the bar diagram, and set up that equation, and then work backwards. If you use those 3 steps, then you'll be able to solve 2 and 3 on your own. So please go ahead and do that, and I'll show you the answers when you come back. Pause now. And here are the answers for number 2 and 3. So for number 2, I made the variable x for Clinton's money that he originally had. It said that he spent $5. That means he subtracted $5 from the amount he started with. So I did x minus 5, and it says that he was left with $12. So I did x minus 5 equals 12. When I did my addition backwards, when I worked backwards, I have 12 plus 5. And of course, 12 plus 5 equals 17. So x, the amount of money that Clinton started with, was $17. For number 3, Martin County Cat Shelter placed 8 cats with new owners on Monday. On Tuesday, 31 cats remained at the shelter. How many cats were at the shelter originally? So originally, I'm going to use C for my cats originally in the shelter. And then we know that we placed 8 cats with new owners. That means that we subtracted 8 from C to get 31 cats that remained. So if we work backwards and we do addition backwards, we do 31 plus 8, and that equals 39. So C equals 39. There were 39 cats originally in the shelter. Now for number 4, it says write a rule for solving equations like x minus 4 equals 7. And then number 5 says write a real-world subtraction problem for the equation modeled below. Then write the equation and solve. And it gives you miles driven m, and it tells you 128 miles and 67 miles. So come up with these answers for 4 and 5, and we'll come right back and I'll give you some answers of my own. Pause now. Okay, now your answer might be different than mine, but the gist of it should be that for number 4, what is the rule for solving equations that are subtraction with variables? That we want to work backwards and add, okay? Working backwards and adding. That would be the rule I would think of. For number 5, write a real-world subtraction problem. So I just came up with, I was driving to Disney. I drove 67 miles but had 128 miles to go. How far is it to Disney? Something like that would be a subtraction problem. It's the, it would be, you know, x for Disney, the miles to Disney, minus 67 equals 128, and then we'd solve it from there. It says to solve the equation, so to solve it, we're going to add backwards. So we're going to do 128 plus 67, and that answer is 8, 9, 195. Yeah, 195 miles to go to Disney. Okay, so that would be the answer. So it said to write the equation. So here's my written equation. I wrote my little story, and then I did my miles total, and that's 195 miles. So regardless of what your story is, you should have this and this as your final answers as well. All right, and the final thing, the question going back to the beginning, is how do you solve subtraction equations using models? Well, obviously, we've talked about working backwards, and when we set up the models, we can see that this is the total distance. Here to here, we went so far, and then here to here, we went so far, and so if we know that the total amount is combining these two numbers, then we are adding, working backwards and adding. And I think it's pretty obvious too. When we say that this is 3 and this is 12, I think it's pretty obvious that this combined would end up being 15. So I think using the model is really, really helpful. I hope you have a great day. See you in school. Bye.